Thanks for coming today. We know that Aaron Patterson's next door, so you must really want to hear about JRuby. Hi, I'm Tom Enebo.
And I'm Charles Nutter.
We've been working on JRuby for probably more than 15 years.
Seems like forever.
And we work for Red Hat, which is gracious enough to pay for us to work on JRuby. So if you take away anything from the talk today, it's just that we're another Ruby implementation. We aim to be as compatible with 2.5.7 as we can. In the next major release of JRuby, we're going to be aiming for 2.7, sometime after 2.7 comes out. We happen to run on top of the Java virtual machine, and we do actually have some extra features that you can leverage from Java. But if you never use those, you could just think of this as just being a Ruby implementation. About 2 weeks ago, we put out 9.2.9. We've been spending a lot of time working on memory improvements from 9.2.7 to 9.2.9 on like a single controller Rails app. We've dropped our memory use by about 24%. We've also made a bunch of improvements on startup time. Pretty much any command line you'll notice it's a little bit faster than it was. We're always fixing options, and the Java module stuff Charlie will talk about later. There's 3 steps to getting JRuby. The first one is that you need Java. So if you type java-version and it returns something that's version 8 or higher, you're golden, although we recommend 8 or 11 because those are the long-term support versions of Java. If it's not installed, use your package manager to install it, or you could go to adopt OpenJDK and download it yourself. But once you have that, then you just use your favorite Ruby manager to install JRuby. So this is exactly like using CRuby, right? And I can't see when, I can't see when that finishes. All right. So alternately, if you're on Windows, you might want to go to our website and download our installer, because that's sort of the Windows way. But there is no step 3. So once you have Java, this is no different than working with any other Ruby. But it's easy enough to install, but why would you want to use it? And what differences are there with CRuby? Probably the biggest feature we have is that we can concurrently execute Ruby with native threads versus CRuby, which has a global interpreter lock. They actually can do stuff across threads, but it's only when like a system call's executing. And so you don't normally see much benefit from it. Oh, I keep hitting the down arrow. So here is just a simple micro benchmark. We make a big array. 10 times we go and each through it. This is just with one thread. And then we have a second benchmark where all we do is for each of the 10 times we walk the array, we create a thread, and then we join on it to make sure all the threads finish. Highly contrived, but if we actually look at the single-threaded run, what we see is a single core is pretty much dominated with all other cores not doing much. Once we switch to the multi-threaded thing, if you look at the CRuby on the top right, you can kind of add up those blue blocks and fill it in on the left side, and you'd kind of see the same CPU utilization. If you look down at the JRuby side, we're not only jamming on all the real cores, we're also filling up the hyperthreads. If we actually look at the tan bars here, you can see on CRuby, there's really no change in performance here. It takes about the same amount of time between both. So threads don't help. If we actually look at the blue bars, you can see that we went from 0.23 to 0.15 for this. And this is highly contrived, but you can see that it's obvious that threads are helping us. And Charlie's going to be covering some more real-world application performance with threads later. Another fairly big difference is that we're built on top of a virtual machine versus doing it all ourselves. So we both have our own teams. Sometimes these people are in both boxes, and we have to write to our host. If we look at JRuby, we do some POSIX calls straight down to the operating system to try to be more compatible with CRuby. But for the most part, our host is the JVM itself. Oh, I got a little too fast there. OK, good. And MRI doesn't really have any dependencies other than the C compiler. From our perspective, this isn't as good as being built on top of the JVM because they have the control to do anything they want, but they have to do everything. If we consider this from what we get by building on top of the JVM, there's entire teams of people that have been working for decades to continue to make the JVM execute code faster and faster. And we get tons of stuff for free. There's multiple garbage collectors. We talked about threading already. Charlie will talk about how awesome just-in-time compilation is to generate native code and then profile that and make it even faster. You'll also be talking about tooling, and it runs everywhere. And in fact, there's not just one JVM. There's multiple ones that you can choose. Hotspot's the one that you're most likely to use, but IBM has OpenJ9. So like one really nice feature that they have is when you execute code with a flag, it'll notice all the classes that you use, and it'll save it off to a space. And then the next time you run it, it'll fast load that stuff that it loaded from last time, which will help startup time. GraalVM is actually its own distribution, but it's also something that plugs into Hotspot that replaces one of the just-in-time compilers. Sometimes the performance is really fantastic, but in practice for larger applications, it seems to be about the same as OpenJDK. On the other hand, it's a fairly active project, so who knows what's going to happen in a year or sometime in the future. As I said, it's absolutely everywhere. We actually have users on VMS. We had, at least in the past, someone on an IBM mainframe. It's pretty scary. We also compile all of our stuff down to Java bytecode, which is platform agnostic. And this gives us a level of portability that's great. So here's our Java native extensions that we have. But when you do a gem install, there's no compile step because we already compiled it when we released the gem. We have a different extension API than CRuby. I think we all know this. In general, these extensions exist to give better performance because Ruby isn't always the fastest language in the world. But also, people aren't going to rewrite OpenSSL in Ruby, so it's kind of useful to be able to call out to a C library or a Java library. If we actually consider the C extensions themselves, it's massive because it's basically every C function in the code base is potentially usable by any C extension author. Typically, there's a small set that most extensions use, but in JRuby 1.6, we actually had experimental support for C extensions, and it ended up being kind of a support nightmare because we get this endless stream of, yeah, but you didn't implement this, this method. On top of that, because Ruby can't concurrently execute code, sorry. That hit this spot. Because we can't concurrently execute Ruby code, then the C extensions weren't written to be concurrent in the first place. So we ended up having to put a lock around any calls out to the C extensions, which then kind of killed a significant reason for using JRuby. If you have multiple threads but you're always locking, then you get behavior like in the earlier slide throwing how MRI behaves, essentially.
Right. All the extra overhead of having to sort of protect the C code basically killed most of the benefits of having C extensions running in the first place. It just didn't gain anything, and it was a huge support cost.
And we also already had Java native extensions, and they actually ran faster. So it was frustrating when someone had used the C extension instead of our Java native one. This is also a big API because it's also our implementation. We have plans to change that, and it's embarrassing that we haven't done it because We've had this plan for years. But obviously, we can do concurrent execution. We have almost no cost in our API because it's our implementation. And as you saw on the previous slide, we have lots of native extensions already. As a side project, I've been working on OJ, which is a very popular JSON library. It pretty much does anything you could want to do with JSON and a few more things beyond that. And it's increasingly becoming an important transitive dependency. So at this point, it's nearly done. It's about 9,000 lines versus 20,000 lines. Java object orientation for the win. Oh, this test results are wrong. There's only about 15 errors right now, total. If we look at load performance, this was just off of some website where they had a small, medium, and large payload. If we look at the blue line, this is MRI running OJ, and then the yellow line is us running OJ. You can see we're about 1.5 to 3 times faster than CRuby. The green line we just put for convenience. This is actually the psych or default JSON gem that we ship. So if you're already a JRuby user, OJ is going to give you a huge boost if you're doing a lot of JSON.
And this is really interesting to us because largely this is the same code, the same logic from OJ is just ported into JRuby's extensions and running on the JVM. But the fact that we have this excellent profiled JIT, this awesome garbage collector, it all integrates and compiles together. Not only can we run essentially the same code, we can run it this much faster. And we can run it with concurrency. So it seems like clearly the win is to have whatever extensions we run implemented on that VM.
That's right. Dump performance isn't currently quite as fast in comparison. We still do win. There's one significant optimization that needs to be added. I don't know if it'll be the same ratio, but it'll definitely be faster.
All right, so one of the other big advantages that we have being on the JVM and just fitting into any standard JVM out there is being able to call into all the other JVM libraries that exist. Of course, we can access Java classes. We have a nice syntax for it. You basically can require in a jar and start accessing the classes as if they were just regular Ruby classes. And now that doesn't mean just Java. That can be Clojure, that can be Scala, that can be anything else that runs on the JVM. And there are tens of thousands of libraries out there. If there's a library for something you need, there's probably a dozen of them implemented on the JVM, and you can just start using that directly. Quick little run-through example of using Java library from IRB. So here we have our IRB shell. We're actually going to use the Swing GUI framework, which is built into OpenJDK. We can create a new frame with a title on it. We can create a button and put that into our frame. And these are all just standard Java calls. We're just accessing the classes from the JVM directly. Set our size to something so it's reasonably visible. And then we get our window popping up. We can add an action listener here using standard Ruby sort of semantics. Notice this is add underscore action listener. We convert most of the Java names so they look like Ruby, so that it fits into the nice flow of your program. And then once we've got that, we actually can use this GUI, and it's all scripted from Ruby. So just a few lines of code, and you can use Java Swing, you can use Java FX for doing GUIs across all platforms. It'll just run with this Ruby script and JRuby installed. Of course, there's a lot more fun things we can do. Minecraft, the main version is still implemented in Java. Here is an example of using the plugin library, which is a library Tom wrote to allow scripting Minecraft plugins entirely from Ruby. So this code on the left basically changes the number of chickens that are hatched whenever you throw a chicken egg from the 1 or 2 that it normally does to 120 chickens. And I think you actually kind of messed your world up on this one by playing with it.
This is a great way to destroy your server.
All right, so getting back to something a little bit more practical, we'll talk about various aspects of performance. Like we say, we always try to make JRuby perform well, run applications well, so that there's a benefit for you moving other than just being on the JVM. We always want to get this out of the way to begin with. Startup time is certainly one of our weaker areas. All of these runtime optimizations that we do internally, that the JVM does for us, these really do give us excellent performance, excellent peak performance once everything is running. It just, sometimes it takes a while to get there. So as a result, startup time is impacted. There's a warm-up curve to get an application up and going. We continue to improve this. We're adding new ways of starting up JRuby that start up faster. We're tuning our own JIT and working on tuning the JVM JIT to reduce warm-up time. But it is still something to keep in mind when you start using JRuby. So comparing a few simple commands here in just a moment. To illustrate why this is, why we have this warm-up and startup time, I just want to demonstrate what the process is for JRuby to get Ruby code running. So we start with our Ruby code here on the left, and we parse that into parse it into an AST and compile it into our internal instructions. That parsing and compiling is all written in JVM bytecode that the JVM needs to optimize. So that's the first step that we start out running cold with. We have our own interpreter for our internal instructions. So we pass off our instructions to our interpreter, also written and compiled to JVM bytecode, so the JVM has to take some time to optimize it. And then continuing on from there, we do eventually turn the Ruby code into JVM bytecode directly. That runs on the JVM, and it continues this same process. So all of these different phases each do their own little bit to help optimize Ruby code, but it takes a while to get there. It takes a while to spin it up, to figure out what the hot code is, and to do all those optimizations. Eventually, though, we do get to the point where we reach a steady state performance, and we have full-on performance from the JIT and from our internal optimizations. Now, knowing that most of these steps are not particularly important for running day-to-day commands, like listing gems that you have installed, installing a gem file, starting up a Rails console, we've introduced a flag to JRuby some time ago, --dev. What this flag basically will do is turn off some of our internal JIT optimizations. It will simplify the JIT optimizations that the JVM itself does. And as a result, it can cut a whole bunch of those extra stages out. This ends up giving us like a 30 to 40% reduction in the startup time of most commands. So this is definitely the first line of attack for improving JRuby startup time. Another example here comparing to CRuby. Here is about how long it takes to list about 350 some gems on a system. And there's what it is with JRuby dev. So it's about a 3x slowdown in this case. Now, the larger command that you run, if you were to switch to running Rails console, both of us have a lot of work to do. So the more work you do, the longer JRuby runs, the less that startup time tends to be an issue. It's just for the really shortest things that you notice how much of a difference there is. A feature that's being pushed on OpenJDK side more and more is called class data sharing. Basically, what this can do is help us skip a few of those steps. When it loads in the code, it already knows that it's valid, it knows how to optimize it, it can get things running a bit faster. If we combine this class data sharing feature on more recent JVMs with our --dev flag, that's currently getting us down to our best startup time at this point. So we're working on various ways of making this simpler. So all you have to do is install a gem, and then it will set up all this CDS stuff for you and have your startup time a little bit improved. So that's the startup time situation. We'll move on to actual application performance. Once we've got an app up and going, what sort of performance are we expecting out of it? We have two different scales of applications here. One is just a very small, like a microservice style application with a Sinatra or Rhoda behind Puma. Very trivial, simple little server. And we'll compare JRuby and CRuby, and then we were able to get some Truffle Ruby stuff running here for folks that are interested there. We also have now been running the Redmine bug tracker. So the same bug tracker that is at bugs.rubylang.org runs great on JRuby. We actually only had to make a couple minor configuration changes. And so that's a better test of a full-size Ruby Rails application. So first I'm going to talk about peak performance here. So this would be after the startup time, after the warm-up curve is settled. Folks will sometimes exercise the server for a couple minutes just to make sure that it's hot, everything's cached. And that kind of applies to most implementations anyway. So like I say, we generally do get better peak performance, but we'll talk about the warm-up curve in a little bit here. So here is Sinatra and Rhoda, requests per second, comparing the implementations. Starting out here with CRuby, about 12,000 requests per second on Sinatra. JRuby getting close to the 4x range on this particular one. So very small microservices, very small applications, optimize very well on JRuby and will perform significantly better than on CRuby. I think TruffleRuby has some concurrency issues that might be slowing this down. This is running with like 8 concurrent workers or 8 concurrent threads, and we just didn't see any gains from the extra threading here. Similarly, on the Rhoda side, about 14,000. It's a little bit lighter framework than Sinatra, but a similar ratio for us running some simple web microservice like that. And a bit of improvement here. Rhoda definitely is a lighter weight framework from Sinatra. So if we look at something bigger, here's our Redmine results. So 41 requests a second for CRuby versus 50. That's on fully rendering an issue screen. I think part of this is just the way that Redmine ends up rendering all of this extra string data to send it out to the browser. We're not getting as much of a gain there, but as with the microservice, if you're using this more as an API and you're just getting the JSON result, then we've got a good 30% improvement over CRuby here.
And we did notice a couple of small bottlenecks once we started benchmarking Redmine, so this is fun.
Right. Redmine has not had a lot of optimization work. I'll tell you that right now. So we're going from, remember, the previous one was tens of thousands of requests per second down to double digits requests per second. A lot of that is lots of legacy code in Redmine using the old way of doing things in Rails. We've actually been doing some profiling and probably will work with Rails and Redmine folks to optimize some of this stuff. So then finally, a little bit of discussion about the warm-up time, how we get to these peak performance numbers. Larger applications take longer to warm up. More code has to be compiled, has to get into the JVM and optimize. And like I said, we're working on new ways of tuning our JIT, tuning the JVM JIT, to try and reduce this curve a little bit. So here's what it looks like with Sinatra. These are 10-second increments, so basically hitting the same action for about 10 seconds just to make sure it's warmed up, the JVM knows it's hot. After the second iteration, then we start to pass CRuby, and you can see it starts to go way up at that point. The JVM JIT is now taking over, turning it all into native code. Rhoda being a little bit simpler, we actually start out pretty close to where CRuby is, and then almost immediately we are showing improvements. So again, smaller applications, smaller microservices definitely have a smaller, less of a hit from the warm-up time. Here is Redmine. This is just the JSON version of it. It takes a couple minutes of warming up to get past this point. Part of this is our JIT, but part of it is just we're throwing so much code from a typical Ruby Rails application at the JVM that it just takes a while to actually compile and optimize all that stuff. We're hoping that we can reduce that curve a bit, try and give it some hints about what needs to optimize earlier on. But by the third or fourth run of this, we actually do pass CRuby and then continue to get faster from there. And so then finally, the last aspect here is what it takes to get the good concurrent performance that we're seeing on these applications. And now if you were to just run this out of the box with JRuby, we're throwing 8 threads on JRuby's side versus 8 workers on CRuby, trying to make sure that we have somewhat equivalent concurrency configuration here. Without any tuning, we will probably use more memory. The JVM likes to eat up memory. If you've got 2 or 3, 4 gig, it spreads its legs, so it spreads its arms so it can actually get a lot of room to do all this work. But this last column, the orange column here, we can actually run these actions in Redmine, choking JRuby down to only a 300 megabyte heap rather than about a gig. And then the additional JVM stuff brings us up to about 800. So we're saving memory here over running the equivalent concurrency level in CRuby for a pretty large app.
Just an extra note is that we did try running 4 threads per worker, and we did not actually notice a performance difference. So that's why it's just 8 workers.
Yeah, oddly enough, if you start throwing multiple threads at CRuby, it actually ends up slowing things down most of the time. So unless you've got a lot of blocking calls to a slow I/O source or a slow database, really workers are the only way you get scale out of CRuby, and that means a lot of duplication.
All right, so most of you are CRuby users, and your first activity is going to be to migrate an existing app to JRuby, so let's walk through that. even if you did a new application, these 3 items are important to you as well. There'll be a few small configuration changes you'll make. Usually it's just the database. You have to deal with what C extensions exist or you know about and what you have to replace them with on the JRuby side. And you have to make sure it's thread safe, because if you can't execute across threads, you're not going to get the decent scaling that we showed earlier. The use case is we've been trying to get Discourse to run. It's a massive application. There's more than 500 gems used. And you know, it sort of works. It starts up. I can go to all the pages. The only thing that doesn't work is the main content pane has no data. So what's happening is it's taking Markdown format and then using JavaScript on the server side to render it as HTML. And for some reason, JavaScript is not executing right for us, which should have nothing to do with JRuby. But there you go. Once we get that fixed, this will be a fantastic milestone, because if we can run Discourse, we can run anything.
Right, and really all of the Ruby code that's involved in Discourse here is working. It's this one last call out to JavaScript to render stuff.
And it is doing something in JavaScript, we just don't know what. So the first thing that we did when we tried to tackle this is we installed the JRuby lint gem. So you install it, you go into your app directory and you run it, and then that's what a report looks for 250,000 lines of Ruby.
Hopefully you don't have as large an application to run this against, but lots of tips here.
So the very first thing that it does is it looks at your gem file, and then it says, oh, JRuby can't do PG. You should go and use Active Record JDBC PostgreSQL adapter. I know that's a tongue twister of a name. But where we get this is from our wiki, where we actually have documentation as to what could be a replacement for an existing C extension API. The majority of the report are threading concerns, and almost all of them are or equals. This is not an atomic operation in Ruby.
In any Ruby.
In any Ruby, correct. And although it might just happen to work, which is why there's so many of them. But in general, you just have to evaluate each of these and say, can 2 threads hit this at once? If it happens as your app is bootstrapping, then that's all happening on the initial core, and you don't have to worry about it. Otherwise, you might have to put a lock around it. For optional features that we decided to turn off for performance reasons, it'll tell you about those and how you can turn them on. For things that we don't support, there's not too many of those, but fork is something we'll never support. I know, never say never, but we'll never support fork. And at some point, you have to start dealing with native C extensions. We got some hints from the tool, but at some point you hit bundle install and you run into your first error. In this case, I already talked about PG, and this is the recommended way to solve this. You just put a platform tag so you can still run bundle install with MRI, but then you can also run it with JRuby. At some point, you may realize that there's just not an equivalent, and then you have to come up with a strategy for that. We don't have a direct analog to buy-bug. There is something that's similar, but it's a good example because it shows up in a lot of development sections of gem files. You can maybe just get rid of that because you just want to see how JRuby works. There's a whole bunch of pure Ruby implementations of gems, but they've fallen out of favor for someone's du jour C extension. Maybe you can use that. We do execute Ruby pretty fast. Sometimes you do just need to call into a dynamic load library, so you can use the foreign function interface gem using a Ruby syntax to load a DLL and call it C functions. Charlie gave an example of scripting into the Java Swing library, but there is literally a Java library for anything you can think of. So you could do that. That's a pretty fast solution. And last and certainly not least, you can go and write a JRuby Java native extension, which will probably give you your best performance, but it's probably going to be the most work. But once you do it, we all get the benefit. And as you could see earlier, lots of people have taken that hit. And And so the last step is just to go and fire up Puma. This is our recommended deployment, and use threaded, and I don't actually think workers work.
No, doesn't do anything.
So you should just be able to start it up, and your app should just work. If it doesn't work, file an issue, come under our chat channels. We actually have information for that later on in the talk.
So usually at this point, if you've got your application up and going and you can boot it and you hit it and it all seems to be working, then hopefully we would see that you're getting better concurrency, better performance out of it. Now, if that's not the case, we do have a whole bunch of tools that are built for the JVM that we can then leverage to help profile, monitor, and optimize Ruby applications. So I'm going to talk about 3 different tools here. We'll go through each of these one at a time. The first one is Visual VM. And this is a graphical console, a very basic graphical console that lets you connect up to any JVM or JRuby application and monitor what the garbage collector is doing, what the compiler is doing, get the basic information about how things are running on that system. And this has been open sourced as part of OpenJDK. If you go to visualvm.github.io, there's downloads that you can pull down, and they'll just let you connect up to whatever JRuby instance you want. So if you get in there, you'll see on the left side here, it recognizes that it's a JRuby application. If we connect into that, we can get some live views of the application. So on the left here, just the basic metrics of the environment. We got CPU monitoring, the overall heap monitoring, information about classes and threads that have been loaded in the system. On the right is the Visual GC plugin, which you can install in Visual VM from the plugins menu. And this is a live view of what's actually happening in the garbage collector. It shows the different generations. It shows it filling up and clearing out, objects getting promoted. If you don't see a nice sawtooth where it always generally goes back down to the same level, maybe there's a memory issue. If you see that it's spending a tremendous amount of CPU time, maybe there's too much allocation. Maybe there's a wasted, like a fast loop that's allocating too many objects. But it gives you a really good view into what's happening on a live JRuby instance. So for a little bit deeper information, we can go to the JDK Flight Recorder. This is a feature built into OpenJDK, and you flip this flag on, and then it will basically be waiting for monitoring commands. Those monitoring commands will come from the GUI client, JDK Mission Control. So if you go with you download Mission Control, adoptopenjdk.net has builds of this. I think some of the Oracle builds include this along with the standard JDK build. So we'll start out, we see various JVMs that are running on the system, and we tell it to start a flight recording. In this case, I have tweaked the settings for the flight recording a little bit to also include object allocations, and this will track all objects that are being allocated in the system and give you a stack trace to say where they were. You can find the most expensive pieces of code and go in and fix your Ruby application. Once it's done running, you get a basic information. You can drop down each of these, see where all the allocations are happening, see what sort of locking problems there might be slowing down the application. But then it gets into some very detailed views. Here we have a view of objects that are being allocated, the top objects in the system, also showing the rate of allocation in those blue bars and the size, the amount of memory of the heap being used. So we can see the garbage collector sawtooth there going up and down. Not shown in this view, down below here you actually can click on any of these objects and you get a stack trace that shows where in JRuby or where in your Ruby application all of those objects are coming from. Similarly to memory profiling, we have method profiling. So this will track where in JRuby or where in your application we're seeing the most expensive hits. The Ruby code will show up in here along with JRuby internals, and we're working on some simple ways to filter out if you just want to see what the Ruby code is. But oftentimes it's actually important to be able to see into the implementation. That's much more difficult to do with CRuby at this point. Finally, here's a view where you can see all of the threads that are running in the system. I think this one had, this was a run with 32 threads, so we see most of those on the side there. The green shows that it's actually working. I think the yellow was that it's waiting on input, so perhaps waiting on a select loop for a next request to come in, something like that. And you can see some of the GC threads also show up in here. So you get a view of how well you're utilizing all of those threads. If you only see one thread really getting a lot of use, maybe there's a lock, maybe there's a bottleneck there that you can dig into a little bit further using this tool. The last tool I wanted to mention is Async Profiler. So this is, the GUI client's really nice, but a lot of times we don't have that kind of access to a production environment. We're throwing it into a container on a cloud somewhere. Trying to get all those ports to map up so we can connect up a GUI is not always the greatest way to try and do profiling. So Async Profiler can run just at a command line. It can output a text file for you. It can output an SVG file of a flame graph. And we are working to make this sort of integrated into JRuby. You can gem install JRuby-async-profiler right now, and it'll pull down this code for this JVM extension and build it and put it in a place where JRuby can find it. We're going to add some additional features to make it simple command lines. So you can say JRuby profile memory, it'll run your application, and then dump out a profiled file. But if you want to try and do that now before we have the easy commands, you can take a look at the Async Profiler site here, their project, which will show you the command lines that you would need. And as I mentioned, we get nice little flame graphs like this that will show where in our application the performance is actually going away, what's taking up the most amount of time. And this is all very lightweight. Just like the flight recorder, maybe 1% impact to your application. So you can have flight recorder ready in production. Will have no impact until you run the flight recording. But even then, it will only be a couple % difference for the 1 or 5 or 10 minutes you want to monitor your production app. I don't know of any other profiling tools that can run with that little overhead and give you this deep level of information. So even in production, you can do this. OK, so wrapping up. Looks like we're doing pretty good on time here. So there will be other things that will come up. You'll find a library you can't get a replacement for. You'll get a weird bug. Don't assume it's you. Come talk to us. We have a Matrix channel. We're using Matrix now. Sort of like a Slack sort of thing, but it's open source. It's actual free open source out there. We can run our own instance if we want. This is the place to go. So JRuby on Matrix to find us.
And we're very friendly.
And we're very friendly. We always hang out in there. We love having conversations. And we will never assume that you're doing something wrong. We'll always assume it's us at first. So please talk to us. Of course, we have the JRuby project. We have an extensive wiki. There's documentation on the async profiler stuff, all the new features in 9.2.9. There's a little bit of traffic on the mailing list, but mailing lists seem to be kind of falling out of favor in preference for forums and chat rooms. Remember, during development, if you want to avoid some of that startup time, the --dev flag, we recommend putting it in an environment variable because a lot of Ruby commands launch subcommands, and you need those flags to all get passed through to all the additional processes. We constantly stumble over Ruby version. I know it's really helpful for some folks, but the fact that you can only say one exact Ruby that you want to switch to means frequently you'll change directory out, change directory back in, and you're no longer using JRuby again.
And
it silently does this.
And you have no idea.
And you have no idea. And suddenly performance isn't as good. Oh, what's wrong with JRuby? Oh, it's switched for you. So keep an eye on that. And if you have multiple Ruby implementations, generally don't share gem paths. Most of the Ruby switchers will take care of this for you and isolate Ruby gems from JRuby gems. But the extensions and whatnot, of course, are completely different and not compatible. A quick note about Java module system. If you start running on Java 11 or anything Java 9+, you'll see some warnings about JRuby accessing internal classes, accessing parts of the JDK. These are harmless warnings, but they are kind of annoying. We are working on various ways to limit these warnings, to open up the right packages, make sure that JRuby can access what it needs to. There's an example of what the warning looks like. An illegal it's terrifying sounding. Illegal reflective access. Please consider reporting this. It's illegal. It's so illegal. There's like 10 illegals in this warning. I think they really want to get the point across.
Java loves lots of lines, too,
yes,
in warnings.
Yes. It could have been 2 lines, but no, it must be 5 lines and 10 illegals. But then basically it'll boil down to like a simple flag to say, yes, JRuby actually needs access to these internal classes. Open those up. And like I say, we've got some information on the wiki about how to make this translation. And you can add these to our JRuby Java opts file. that will then apply globally, and you won't have to worry about it anymore. So please give JRuby a try. If you're still using it, let us know your story. We always hear from new JRuby users every time we come to a Ruby event. And if you have any issues, just stop by, ask us a question while we're here at RubyConf, or stop in online on Matrix. And I think that's about all we got.
Well, and